Do you often use disposable plastic cups and containers? Did you know that every year the world generates over 300 million tons of plastic waste, with a significant portion coming from single-use products? Alarmingly, only about 9% of this plastic is recycled, while the rest ends up in landfills or pollutes our oceans, severely impacting the environment and threatening ecosystems. So, is there a viable alternative to these plastic products? Join IronHand Tech in today's video as we explore a sustainable solution. When people think of sugarcane, they usually associate it with sugar production. However, few realize that in addition to its primary product, the sugarcane industry also generates a valuable byproduct, bagasse. Instead of being discarded or merely used as fuel, bagasse is now being repurposed to create eco-friendly alternatives to single-use plastics, helping to reduce environmental pollution. Let's dive into the process of transforming bagasse from waste into practical, everyday products. Sugarcane typically takes 10 to 14 months to mature before being harvested. After the juice is extracted, the remaining fibrous material, known as bagasse, is often discarded or used as fuel. However, thanks to modern technology, bagasse can now be recycled into eco-friendly alternatives to single-use plastics. But before it becomes a finished product, bagasse must undergo a rigorous processing procedure. The first step is to remove impurities and residual sugar. Bagasse is washed with hot water to dissolve any remaining sugar, preventing fermentation and bacterial growth. Next, it is pressed to remove excess moisture before being fed into a coarse grinding system that breaks down its original structure, preparing it for the pulp-making process. The material is then finely ground into pulp, the key raw material for producing these products. The moisture content of the pulp is carefully controlled to ensure strong adhesion without the need for harmful chemicals. To enhance product quality, natural additives may be incorporated into the pulp before molding. These additives help increase durability, improve water resistance, and maintain the product's shape. Many manufacturers choose to retain the natural color of bagasse to ensure biodegradability after use. Once thoroughly mixed, the pulp mixture is ready for the molding stage. One of the most crucial steps in the process is shaping the products using vacuum molding technology. Metal molds designed in the shape of cups, bowls, plates, and more are dipped into a vat of liquid pulp. The vacuum suction causes cellulose fibers to adhere tightly to the mold, forming a layer of pulp with the desired thickness. Excess pulp is removed to ensure uniform product size and shape. The molded products are then dried and heat pressed to enhance durability. Any leftover material is trimmed either through industrial processes or manually, depending on the scale of production. After drying, the products undergo a quality inspection before being packaged and distributed to the market. Plates, containers, and cups made from bagasse are not only durable and aesthetically pleasing, but also fully biodegradable. They can completely break down within 90 days, leaving no microplastics or harmful chemicals behind, significantly reducing waste from the sugarcane industry. You can safely use these products for food and beverages without worrying about health risks. The biggest difference between bagasse-based products and single-use plastic lies in their entirely natural origin. Even the additives used in production are safe and biodegradable. This means that by choosing these products, you are actively reducing plastic waste and helping to protect the environment for future generations. Isn't that amazing? However, challenges remain in bringing bagasse-based products to the market. They are typically 20% to 40% more expensive than plastic alternatives, depending on the type of product and the supplier. As a result, consumers often opt for cheaper plastic options for similar usage. Changing consumption habits is not easy, but as we know, the best way to reduce plastic waste is not just recycling, it's avoiding plastic use in the first place. If everyone reduced their plastic consumption by just 1% each day and switched to alternatives like bagasse products, we could cut down millions of tons of plastic waste annually. This would not only protect ecosystems, but also ease the burden on landfills and overwhelmed recycling systems. To make this shift happen, Governments must take action by implementing policies that promote and encourage the use of eco-friendly products. There should be incentives for businesses producing green alternatives. After all, they shouldn't have to fight alone in this noble mission to protect our planet. From what seemed like a discarded byproduct, bagasse has been reborn into useful products, contributing to a more sustainable lifestyle. Are you ready to change your plastic consumption habits and join hands in protecting our planet? Let's spread the use of eco-friendly products and preserve the Earth for future generations. Thank you for watching. Don't forget to leave your thoughts in the comments and share this video to spread positive impact. See you in the next video. You are holding a straw in your hand, a small object that seems harmless. But according to the National Park Service, the United States alone discards approximately 500 million plastic straws every single day, an alarming and staggering number. And as National Geographic reports, plastic straws can take anywhere from 200 to 500 years to fully decompose in nature. In contrast, paper straws take only 2 to 6 weeks to completely break down. So, how are paper straws made? And are they truly a better alternative to plastic? Let's explore the production process of paper straws to find out. It all starts with the raw materials. Plastic straws are made from polypropylene, PP, a durable plastic that cannot naturally decompose in the environment. Nowadays, PLA bioplastic straws are being produced and praised for their eco-friendly features, claiming to decompose in a short period. However, PLA only biodegrades under ideal industrial conditions. Otherwise, it may take 20 to 80 years, or never fully decompose. According to National Geographic, over 90% of plastic straws worldwide are never recycled, and most end up in the ocean, harming marine life. So what makes paper straws different? Paper straws are made from high-quality, food-grade paper, chlorine-free, free from harmful chemicals, and fully biodegradable, without requiring any special composting conditions, unlike PLA straws. However, not all paper can be used. The standard paper for producing paper straws must be virgin craft paper, certified food-grade paper, or water-based coated paper. These types of paper are top priorities because they offer optimal durability, health safety, and are easy to biodegrade after use. After a strict quality control process, the paper is cut into appropriate sizes and prepared for production. Now it's time for paper to transform into straws. Plastic straws are produced through extrusion technology, a fast process but one that leaves a heavy burden on the environment as they cannot decompose naturally. In contrast, paper straws are made using spiral winding technology. Starting from large paper rolls, the paper is stretched and passed through an automatic food-grade adhesive system. This adhesive is made from natural starch, completely safe, odorless, and does not affect the taste of beverages. Once the adhesive is evenly applied, the paper is wound at an angle to form tight spirals, creating strong, durable straws that won't unravel, optimize material use, and most importantly, remain fully biodegradable after use. As a result, paper straws are quickly and efficiently formed, ready for the next stage of production. Once formed, the long paper straw tubes are fed through a cutting machine and sliced into shorter pieces, perfectly sized to fit different types of cups. What's special is that, thanks to the use of premium paper with natural water-resistant properties, there's no need for additional plastic-like coatings as before. Yet these straws still maintain excellent durability when in contact with liquids, allowing you to enjoy both hot and cold drinks comfortably within a reasonable time. Have you ever worried that paper straws might fall apart before you finish your drink? Trust me, if you leave your drink long enough for this paper straw to lose its form, chances are your drink won't taste good anymore either. Just kidding. But honestly, that's the truth. Finally, the finished paper straws are safely packaged in eco-friendly materials. Unlike plastic straws, which are usually wrapped in plastic packaging, paper straws are packed in recyclable paper bags or cardboard boxes, making them easy to recycle and kinder to the environment. According to Ocean Conservancy, millions of marine animals die each year due to plastic waste, and plastic straws are among the most common culprits. By choosing paper straws, we can reduce tons of plastic waste every day, helping to protect marine life and preserve our shared environment. So in the end, which one wins? Plastic straws are cheap, durable, and water-resistant, but they come at the high cost of severe environmental pollution. Paper straws are eco-friendly and safe for your health, even though their production costs may be higher. Your choice today will decide the future of our planet. Next time you enjoy a coffee or bubble tea with a straw, remember, you are choosing between plastic and the future of our environment. If you found this video meaningful, leave a comment and give us a like to help spread this message. Thank you for watching and see you in the next video. Did you know that every year millions of hectares of forests are cut down to produce paper? Pine, eucalyptus, and oak trees take decades to mature, yet they are harvested in just a few hours. This leads to environmental degradation, ecological imbalance, and the release of large amounts of CO2 into the atmosphere. Meanwhile, bamboo, a plant that grows 10 times faster than traditional trees, absorbs high levels of CO2 and regenerates naturally without the need for replanting, could be a revolutionary solution for the paper industry. But is bamboo paper truly superior to wood-based paper? Is the manufacturing technology advanced enough to turn bamboo into a sustainable, efficient, and pollution-free raw material? Today we'll explore the optimized bamboo paper production process, one that is not only environmentally friendly, but also resource efficient and has the potential to completely replace wood-based paper. The first major difference between wood and bamboo is growth speed. While a tree takes 10 to 30 years to reach harvesting age, bamboo only needs 3 to 5 years. Additionally, after harvesting, trees require significant resources for replanting, whereas bamboo can regenerate naturally. By keeping the roots intact, new shoots, also known as bamboo sprouts, will grow quickly without the need for replanting. This makes bamboo harvesting far more sustainable. However, not all bamboo can be used for paper making. To ensure high-quality pulp, we must select bamboo plants that are 3 to 5 years old, neither too young nor too mature. Young bamboo contains too much water and lacks fully developed cellulose, while older bamboo has a high linen content, which lowers the quality of the paper. After harvesting, bamboo can either be transported as whole stalks to the factory for further processing or chipped into small pieces at the harvesting site. The latter method is more common today as it optimizes truck space and reduces transportation costs. Chipping bamboo at the source is a crucial step because smaller pieces have a larger surface area, allowing for more efficient pretreatment processes such as steaming, chemical treatment, or enzyme application. Moreover, uniformly sized chips ensure consistent pulp cooking, preventing undercooked or overheated sections that could compromise paper quality. At the factory, the bamboo chips undergo pretreatment before being turned into pulp. One of the most widely used techniques is steam explosion, a high-pressure steam treatment that softens the bamboo fibers, breaks down lignin structures, and minimizes the need for chemicals in later stages. After pre-treatment, the bamboo is fed into a rough grinding machine, where sharp blades cut it into fine fibers. These fibers are then sent to the pulping stage, one of the most critical steps in the production process. In traditional papermaking, the kraft pulping process is commonly used. This method involves sodium hydroxide, NaOH, and sodium sulfide, Na2S, to break down lignin and extract cellulose. While effective, it produces large amounts of alkaline waste, which can pollute water sources. For bamboo, however, we have a more advanced solution: biopulping technology. Some modern factories use microorganisms or enzymes to break down lignin naturally. This significantly reduces energy consumption, aligns with green papermaking trends, and minimizes environmental impact. Next, the bamboo pulp undergoes the cooking process. Here, an innovative method called organosolv technology is used to separate lignin. Lignin is an undesirable component in paper production because it causes yellowing over time and affects paper quality. Instead of harsh chemicals, this process uses organic solvents, such as ethanol, acetone, or organic acids, which can be recycled up to 90%. This not only reduces pollution, but also lowers production costs. Once the cooking process is complete, the pulp is washed and filtered to remove residual lignin and impurities. If white paper is needed, the pulp undergoes chlorine-free bleaching, TCF or ECF methods, to ensure environmental safety. The next step is pulp refining, a critical phase that enhances the mechanical properties of the paper. This process strengthens the cellulose fiber bonds, improving paper durability and strength. If necessary, additives such as starch, rosin, or bioenzymes may be introduced to enhance water resistance, smoothness, or mechanical durability. After refining, the pulp is diluted with water and spread onto a continuous wire mesh conveyor. At this stage, water starts draining, allowing cellulose fibers to bond and form a wet paper sheet. This sheet is then pressed to remove excess water and enhance fiber cohesion. Next, the wet paper undergoes steam drying, which eliminates residual moisture. If a smooth or glossy finish is required, the paper passes through calendar rollers to achieve a uniform surface quality. Finally, the finished paper is cut into standard sizes and either rolled into large reels or trimmed into sheets, ready for use in printing, office supplies, or packaging. After completing the process, bamboo paper is packaged and distributed, offering a more sustainable and eco-friendly alternative to traditional wood-based paper. So, is bamboo paper truly superior to wood-based paper? Let's take a closer look. In terms of resource regeneration speed, bamboo takes only 3 to 5 years to be harvested, whereas trees require at least 10 to 30 years. Regarding the production process, bamboo paper making reduces the use of harmful chemicals, making it more environmentally friendly. Additionally, bamboo paper offers better quality. It is stronger, more durable, and less prone to yellowing over time. However, bamboo paper production still faces challenges. The initial investment costs are high, and technological advancements are needed to compete with the well-established wood-based paper industry. What do you think about bamboo paper? Could it completely replace traditional wood-based paper in the future? Let us know your thoughts in the comments below. And don't forget to like, share, and subscribe for more fascinating insights. Over the past decades, humanity has been facing a plastic crisis. Single-use plastic products such as straws, plastic bags, and bottles have caused severe consequences for the environment, the oceans, and life on Earth. Every year, millions of tons of plastic are released into the environment. Specifically, more than 500 million plastic straws are used and discarded every day in the United States alone. These tiny straws may be small, but they have an enormous impact on the environment. So how can we reduce this problem? The solution comes from alternative materials, biodegradable straws, among which PLA straws, made from polylactic acid, a bioplastic that can fully decompose, stand out. Today we will explore in detail how PLA straws are produced and why they are considered a green solution for the future. PLA, or polylactic acid, is a type of bioplastic derived from renewable resources such as cornstarch, cassava, and sugarcane. Unlike conventional plastics made from petroleum, PLA is produced through a process of fermenting natural sugars using microorganisms, which is then refined into lactic acid and polymerized into PLA plastic. PLA is fully biodegradable under industrial composting conditions, breaking down into harmless substances like CO2, water, and organic biomass. The advantages of PLA go beyond biodegradability. It is also safe for human health. PLA contains no BPA or other toxic chemicals commonly found in traditional plastics. With its transparent appearance, high durability, easy moldability, and especially its ability to last longer in water compared to paper-based products, PLA is increasingly used in various applications, especially in straw manufacturing. The PLA pellets used for straw production are supplied to the factory in prepackaged bags. These pellets have already met specific quality standards to ensure that the straws produced are free from air bubbles or cracks, while also meeting the required flexibility and color specifications. The PLA pellets are directly fed into the hopper of the single-screw extruder, the core equipment in the straw production process. Below the hopper is a screw that functions to transport, compress, and push the material through heating zones. Here, the PLA gradually melts along the screw at temperatures ranging from 180 to 210 degrees Celsius, forming a smooth and flexible molten flow. The screw rotates at a speed of 50 to 90 revolutions per minute, creating pressure that forces the material through a heat-resistant steel die, shaping hollow straws with precise diameter and wall thickness. After extrusion, the hot straws are passed through a cooling system with cold water. This cooling system includes two tanks with different temperatures. The first tank maintains a temperature of about 40 to 50 degrees Celsius to gradually lower the heat. The second tank, set at 25 to 30 degrees Celsius, completes the shaping process. So why don't we use just one tank with lower temperatures to save water and shorten the process? Because if the temperature difference between the cooling water and the hot straw is too large, the straws may experience thermal shock, causing them to bend, crack, break, or become deformed. The water inside the cooling tanks is extremely clean enough that we could even drink it. So consumers can be assured that the straws are safe to use without needing to be washed beforehand. Right after cooling, the straws pass through a vacuum calibrating machine to ensure their diameter remains consistent and perfectly shaped without deformation. After cooling, the straws are pulled through a system of rollers in the pulling machine, ensuring a stable speed synchronized with the extruder. Next, an automatic cutting machine with optical sensors precisely cuts each straw to the standard lengths of 19 centimeters or 21 centimeters. The cutting machine uses sharp alloy blades to ensure clean cuts without crushing or deforming the straws. After cutting, the straws are transferred to a rounding machine if the product requires it. This step helps enhance safety during use, especially for children. Next, the straws are inspected by an AI-powered camera system that automatically detects defects such as cracks, breaks, deformations, or incorrect sizes. Products that meet the quality standards then move on to the UV sterilization stage, ensuring food safety and hygiene before packaging. Finally, the straws are sent to an automatic packaging machine. Depending on the requirements, the straws can be individually wrapped in biodegradable paper or packed in boxes containing 50 to 100 pieces. All packaging materials are made from recycled materials to ensure environmental friendliness. Each finished product is printed with a QR code for traceability, providing transparency in the production process. PLA straws can fully decompose under industrial composting conditions within 3 to 6 months. During decomposition, PLA breaks down into water, CO2, and organic biomass, causing no harm to the environment. Unlike conventional plastics, PLA does not create microplastics and does not pose a threat to the oceans or marine ecosystems. This is a practical solution to reduce plastic waste and protect water resources. In addition to environmental benefits, using PLA straws also helps reduce the burden on urban waste treatment systems, minimizing the need for landfill or incineration that can be harmful to human health. Although the production cost of PLA straws may be 20 to 30% higher than that of conventional plastic straws, the long-term environmental and economic benefits are much greater. Many countries have implemented high environmental taxes on single-use plastic products, significantly raising the cost of plastic items. Meanwhile, governments in many regions are prioritizing support and tax reductions for businesses that use bioplastic materials. According to statistics from the European and North American markets, up to 70% of consumers are willing to pay extra for eco-friendly products, creating a huge opportunity for PLA straws. Major chains like Starbucks, Highland Coffee, and many five-star hotels have already switched to using biodegradable straws, confirming that green consumption is an inevitable trend. Moreover, when considering the costs of plastic waste management, and the damages caused by environmental pollution, the hidden costs that society has to bear are far greater than the initial investment in PLA straws. This is truly an investment for the future, for a sustainable planet. Let's start making a change from the smallest things. Choosing a biodegradable straw is not only about protecting your health, but also about taking action for the environment. Join us in spreading the message, biodegradable straws, for a greener, cleaner planet. Let's take action together, starting with the smallest things. Just one biodegradable straw you choose today could save a marine creature tomorrow. Let's join hands for a greener, cleaner planet for future generations. PLA straws. A small choice, a big impact. Thank you for watching this video. If you found it helpful, don't forget to give us a like and leave a comment below. Goodbye and see you next time.